Let's have a closer look at the FIA Electric GT category that was presented today. This category was long awaited and it's great to finally see it happening. This new series could be a milestone for future motorsport because it provides a great stage for manufacturers to show their engineering competence. And it's also the first motorsport category in a long time that allows to develop the technology for future road cars and hence is relevant for manufacturers again. Let's have a closer look at the numbers they presented today and what this means for racing. Race cars will have a minimum weight of around 1,500 kg, which is around 300 kg heavier than GT3 cars today. The battery cells will be specialized pouch cells for this series and come from the French company Saft. The maximum battery capacity will be 87 kWh. The maximum power output under acceleration will be 430 kW and a massive 700 kW for regeneration. Since the batteries can withstand that, they can also be charged with 700 kW externally during a pit stop. They say the battery can be charged up to 60% in a few minutes, and we will have a look at how long exactly this will take. Acceleration should be 2.4 seconds to 100 km per hour, which would be another level compared to today's GT3 cars, and the estimated top speed is 300 km per hour. Manufacturers have to use the provided battery cells, but are then free to design their own battery and drivetrain. Rear-wheel drive, all-wheel drive, and torque vectoring will be allowed. And exactly that is what makes it more interesting than Formula E, where teams still have to use spec batteries and companies cannot show their engineering competence. Also, the chassis will have to be road car based, so it's not a spec monocoque and there will be a direct connection to cars on the road. Let's have a closer look at the numbers now. The battery capacity is 87 kWh, and if we want to recharge 60% of that during a pit stop, we have to recharge 52 kWh. The charge curve won't be a flat 700 kilowatt line, but this is motorsport, and the average will be quite high, so I'm assuming 600 kilowatt. This would recharge the 60% in around 5 minutes. If such a stop is really necessary will have to be seen because of the massive regeneration capability. As we could learn in Formula Student, all-wheel drive electric race cars with regeneration can be very competitive and race with relatively small battery capacities. You just need to be able to handle the temperatures of components. It seems like the same experiment will happen here. The next thing are electric motors. If 700 kilowatt regeneration is allowed, teams will go for it. If I then have 4 motors and we assume an even distribution, each motor has 175 kilowatt. But for acceleration, only 430 kilowatt would be allowed. Because the weight balance shifts to the back, you want maximum power at the rear. So 350 kilowatt at the rear axle and the leftover 80 kilowatt at the front axle. That is a 20 to 80 power split under acceleration. And how much is 700 kilowatt regeneration? If we take a speed of 200 kilometers per hour and calculate the kinetic energy, we can then work out how long it will take to brake the car with regeneration only, and ignoring all side effects. 3.3 seconds from 200 to 0. So it's definitely a massive regeneration capability. And very interesting is a look at aerodynamics. If the car can reach 300 kilometers per hour and we assume 1,500 kilograms of weight and a rolling resistance for slicks of 0.02, the power to overcome the rolling resistance is 25 kilowatt. So we have 405 kilowatt left for the aerodynamic drag. And if we assume an air density of 1.2 kilogram per cubic meter, a frontal area of 2 square meter, we get a drag coefficient of 0.58. If we then assume an aerodynamic efficiency, we can work out the lift coefficient and the downforce. F1 cars have an efficiency of more than 4. Good GT cars are around 2. And if we use an efficiency of 2, we get close to 1000 kilogram of downforce at 300 kilometers per hour. It looks like the team around former Audi LMP1 race engineer Lena Garde did a good job working out this racing category, and it should be a good stage for manufacturers to show their latest technology. Additionally, this format has the potential to really develop technology for future road cars, something we have been missing in motorsport for a long time. Let me know what you think about the new Electric GT series in the comments below.